Hi, I'm Richard, and in this episode, we're going to look at our second section of probabilities, and in particular, we're going to look at theoretical probabilities. We can work out the theoretical probabilities involved in an experiment without having to do the experiment itself. So what we can use is assuming that all of the outcomes are equally likely, we can say that the probability equals the number of ways an event can happen, divided by the total number of possible outcomes. So say, for example, we want to know the probability of rolling an even number on a fair dice, then we know that there are 3 ways that we can roll an even number. We can roll a 2, a 4, or a 6, and there are 6 possible ways in total, 6 possible numbers in total that we could get. So we take the number of ways an event can happen, 3, divided by the total number of possible outcomes, which is 6. So 3 divided by 6 is a half. Now, let's look at a different example. If we've got 3 goalkeepers, 10 defenders, and 1 Peter Crouch in a football squad of 44, and 1 player is chosen at random, what's the probability that Peter Crouch is chosen? Well, if there are 44 players and there's 1 Peter Crouch, the number of ways that we can pick Peter Crouch is 1, and we divide that by the total number of players in the squad, which is 44, so 1 over 44. Now, if we've got multiple events, we need to think a little bit differently. Now, let's look at an example where there are multiple events going on that we need to think about. So a spinner has 5 possible outcomes, a dice has 6 possible outcomes, and picking a card from a deck of cards has 52 possible outcomes. What is the total number of ways to spin the spinner, roll the dice, and pick a card? So there's something very easy we can do to work out the number of ways something can happen. So first of all, we need to know, remember, number of spinner outcomes is 5, the number of dice outcomes is 6, and the number of card outcomes is 52. And what we do to work out the total number of ways that those 3 things can happen is we multiply them together. So 5 times 6 times 52, which will give us 1,560 different possible outcomes we can do from spinning the spinner, rolling the dice, and picking a card. So if we want to then work out probability of something happening, say we want to work out a particular number on the spinner, a particular number on the dice, and a particular card coming out, then we could work out how many different ways that is possible to happen, and we could divide it by the total number of ways, which is 1,560. So let's look at it with an example that has slightly smaller numbers so we can sort of get our head around this. So how many possible outcomes are there when we choose a letter at random from the word probability and pick a random day of the week? So there are 11 letters in the word probability. So there's 11 possible things that we could pick from that. There's also 7 possible days of the week we could pick. So to work out the total number of ways we could pick a letter and a day from the week, we do 11 times 7, which will give us 77. So there's 77 different ways we can pick a letter from probability and a day of the week. Likewise, say we want to pick a letter from the word Seneca, and we also wanted to pick another random day of the week. So there are 6 letters in Seneca, there are 7 days in the week. So to work out the number of possible outcomes there are for that, I can do 6 times 7, which can be 42 possible outcomes. So if there are 3 lions and 5 bears at a zoo, and one animal is chosen at random, what is the probability of the animal chosen is a bear? So there are 5 bears, 3 lions. What's the probability the animal chosen at random is a bear? So if there are 5 bears and 3 lions, that means we've got 8 animals in total. and 5 of those animals are bears, so 5 out of 8 would be your answer. Now, again, thinking about the word Seneca, and you're picking a letter from it, and also picking a random month of the year. How many different ways, how many different outcomes can you get from picking those things? So remember, 6 letters in the word Seneca, 12 months of the year. We just times 6 times 7 to give us 72 different possible outcomes. And the last question we're going to look at, to go back to the football example we looked at earlier with Peter Crouch. Say this time we've got 3 goalkeepers and 10 defenders in the football squad of 44, and we choose a player at random, and we want to know the probability of choosing a defender. Well, if there are 10 defenders and there are 44 people in the squad, then it's 10 over 44 is the probability we'd choose a defender. Join us again next time to look at some more maths, and we hope to see you then.